Okay, so we'll do the composites. So what do we mean by a composite? Do you have any examples for a composite? Yes. So and also simplest example is concrete. So you can see the aggregates and you can see the cement paste. So there is a matrix and a fiber. So even if you consider the reinforced concrete, with steel reinforced concrete, again you have steel as the, like, steel will be taking the tensile forces and the cement is keeping the steel bars together. So likewise, if you have two or more materials together, that we call a composite. So we need composites for improved properties. So we have, in a composite we get the benefits of both the materials if we have two materials in the composite. And alloys are not composites. Why it is not a composite? Alloys, you have many materials in alloy, but it's combined together. You don't see the two phases separately. Am I right? So to become a composite, you have to see the two phases separately. Like, there is a matrix and a fiber. Okay. So there are different types of composites. So you can see particle reinforced concretes, where you have particles as the fiber. So there can be large particles or else dispersion strengthened particles. And fiber reinforced composites it can be a continuously aligned fibers like this, or else you can have discontinuous fibers. It can be aligned like this, they are short, or else they can randomly stay like that. And also we have structural composites. It can be laminates and sandwich panels. So I hope you have seen these things. And I have explained in more details during the lecture. So please watch the lecture if you have any issues, anything more to get clarified, or else if you can ask questions. Okay, let's move to the question. First question, for a continuous and oriented fiber reinforced composite, the modulus of elasticity in the longitudinal and transverse direction. So that means when you have a composite like this will be your longitudinal direction and this will be your transverse direction, and this is the longitudinal direction. So stress won't be the same in the longitudinal and transverse. So to find the longitudinal modulus of elasticity, you will use this equation, and for the transverse direction you use this equation. The difference, I hope you can find the difference. So it's like this. So you take the 1 over value for this one. That's how this one came, like 1 over, or so I'll write the equation here. So they are asking you to find, they are saying the volume fraction of the fiber is 0.25. So the volume fraction of the fiber is 25%, and the matrix should be 75%. If the fiber is 25%, matrix should be 75%. So they are telling that and asking you to determine the modulus of elasticity of the fiber matrix. So they have given you the longitudinal direction 19.7 modulus is this in gigapascals, and in the transverse direction it is 3.66 gigapascal. So these two are given to you. Volume fractions also known. So you just need to find out this modulus of the fiber and the modulus of the matrix. So I'll give you a few minutes. You can, here you have to find two things, and you have two equations. So solve the two equations and find the two unknowns. I'll give you a few minutes for you to write the answers. So this will be Vm over E m plus 1 over, sorry, Vf over Ef. So this is simplified like this. Okay, so you don't have to remember any of the equations. The equations will be given to you, but you need to know how to put the values and find the equations, find the unknowns. So So I'll give you a few minutes. Can you please write the two equations, please? Just, yes. I was telling, so we are just started. This is your first question, okay? So composite means you have two or more materials. They are not mixed together. They are staying like, for example, concrete. So you have aggregates bonded together by a cement paste. So aggregate will be the fiber and the cement paste is a matrix. So there are two parts here, fiber and the matrix. Matrix is to protect and also to keep the fibers together, and the fiber is the material which is taking the load. Okay, so there can be different types of composites. So in this one they are saying it is a continuously oriented fiber reinforced. So that means continuously oriented means they are continuous, long, not short, like and also they are aligned. So they are aligned in a direction. So when you have aligned continuous fibers, your properties may be different in the longitudinal direction and the transverse direction. So the modulus of elasticity in the longitudinal direction is given by this equation, and they are saying it is this, and the transverse direction modulus of elasticity is given by the second equation, and they have given you the number for that. Okay, so the properties, when you know the properties of the fiber and matrix separately, you will be able to find the property of the composite using these equations. However, in this question, the property of the composite is given to you, and they are asking you to find the properties of the fiber and the matrix separately. So what I am saying is, this composite longitudinal modulus of elasticity is given. The modulus of elasticity in the transverse direction, composite transverse direction, also given to you, and volume fractions also given to you. They are saying fiber is 25% or 0.25. That means 25%. If your fiber is 25%, your matrix should be 75%, because both together should be 100%. So volume fractions are given to you. Modulus of elasticity of the composite is given to you in both the directions, and asking you to find the EM and EF.
Definitely for numerical, or 3 and 1 short answer.
Both mixed. It's a mix. Yes.
You get 20 out of 34 for yesterday?
No.
Okay, so can we write the equations, please? We have 4 or 5 questions to do today, so you have to do quickly. So 19.7 is equals to EM times 0.75 plus EF times 0.25. So this is first equation. Am I right? Did you get the same? Next one is 3.66 is equals to EM EF divided by 0.5 times EM plus 0.75 times EF. Am I right? So if I write in the same order in the equation, that will be 0.75 times EF plus 0.25 times EM. So these are the two equations. You can solve the two equations. For example, you can make the EM the subject. Am I right? So you have done this in your maths. Am I right? So you can, if you make the EM the subject here, or EF, it's up to you. That will be 19.7 minus 0.25 EF divided by 0.75. So you substitute it here and you get a quadratic equation. So it's up to you whether you want to make this one. Anyway, you need to find both. So you can substitute the EMs here, and you get a quadratic equation, and you know how to solve a quadratic equation, right? So there is an equation for that, minus b plus, so minus b, is that right? Anyway, get the equation, please. Get the quadratic equation and let's see what we get. When you finish, let me know. You need to calculate both EM and EF both. So it's a quad. You have two simultaneous equations, and you're finding you have to find both. You have two unknowns.
That's 0.25.
Yes, it's in the question. 0.25
Square root, or what is it? No. EM equals to 19.7 minus 0.25.
I just substitute the numbers, so you don't have to look at it. You can write your own equation. So these are the two equations you have. Okay, so you write your equation. So if you just substitute this one with the known values, so this is 19.7 and VM is 75%, that means 0.75, and VF is 0.25. so just substitute, and I got this one and this one. Which one you can't read? EM, yes, so that will be just, I made this is 25 EF 75.75 EF. Yes. Okay, when you finish, when you get the two like the quadratic equation, let me know. Okay, and let's see. I have the solution, and we'll see what you get. You get two answers. One is not reliable. Like, always your modulus of the fiber should be more than the, in general, modulus of the fiber should be more than the modulus of the matrix. So you can accept that answer and ignore the other one, because in a quadratic equation, when you solve it, you get two answers, isn't it? So you can select the right answer. So first, can you please get the quadratic equation? Okay, let's see what you got. Okay, so this yes, so when you simplify this EM, I got this, and I have substituted this one here. As the EM. So what did you get for the quadratic equation? Are we good up to here? Any questions? So it's not materials, it's just maths. This is what I got. This is my quadratic equation. So did you get the same? No one is working on this, I think. So when you have a quadratic equation, you know how to solve it, right? So this is b plus or minus b squared minus 4ac divided by, I hope you know this. Yes, so we can find two equations, two answers. We select the answer where your modulus of the fiber is more than the modulus of the matrix. So this is the answer. Do you understand what I have done? So this will be your answer. Are we good? Any question? So you don't know because you didn't do that. Are we good? Okay. Again, I'm telling you, you have one question from this in the final exam. Okay. Are we good? Can I move to the next question? Okay. Okay. So this one, they are saying it is desired to produce an aligned and continuous fiber reinforced epoxy composite having a maximum of 50% volume fiber, 50-50. So fiber is 50% and the matrix is 50%. In addition, a minimum longitudinal modulus of elasticity of 50 gigapascal is required. So the longitudinal value is given to you. So So longitudinal direction equations are like this. So you don't have the transverse direction. You don't have to use the transverse direction. Here they are saying modulus of elasticity should be more than 50 gigapascal. So modulus of elasticity should be more than 50 gigapascals. And as the minimum tensile strength, so tensile strength should be more than 1300 megapascals. They are asking which material can be used as the fiber. So whether E-glass is okay, carbon is okay, or amide is okay. So your epoxy doesn't, the matrix doesn't change, it is epoxy. So it is, it has a 75 megapascal of tensile strength, and also modulus of elasticity is 3.1. Now 50-50, so you have 50% of the 50% of the epoxy, and also you can have the 50% of your fiber. You need to find out which one is okay, which ones are okay, which ones are not okay. So shall we do the E-glass together? So if you have E-glass, how can I write the equation for stress? Stress will be volume percentage is 50-50. If fiber is 50%, the matrix also should be 50% because it should be 100%. So 0.5 times matrix is doesn't change, which is 75. 75 plus 0.5, 50%, and the fiber we are going to use the E-glass, which is 3450. So this will give you the strength. And the modulus of elasticity you can find, which is equals to EM, that is 3.1 times 0.5 plus 72.5 times 0.5. So when you put these numbers in the calculator, can you find me what you get? What do you get? So this one is 1760, and this one is 37.8 gigapascals and megapascals. Am I right? So we need to have more than 50 gigapascals as your modulus and more than 1300 megapascals as your tensile strength. So this is okay, but this is not okay. So we can't use the E-glass. Make sense? Can you check the other two? Your matrix doesn't change. It will remain as the epoxy, and you want to, you have to check carbon and amide. I'll give you time. So find me these two and tell me whether they are okay or not. Okay? Are we good? Any question? Any question? Do you understand what I did? Okay, so I'll give you time. When you finish, let me know. What's that? Carbon is what? So sorry, this one should be here. This one should be here. Okay, that is the yes. So this one is what? What's that? 375. I think I'm wrong. 2015. 2015, and this is 116.5, and the next one is 1950 and 67.05. So both are okay. Am I right? Carbon and these two are okay, but E-glass is not okay. Which are possible candidates and why? You can explain why. Am I right? So these two are okay. Why is that? Because this is more than 1300, and also modulus is more than 50. This is not okay. E-glass is not okay because even though the tensile strength is more than 1300, the modulus of elasticity is less than 50. Are we good? Both have to be more than... Both need to be. Yes, that is the requirement. Okay, I'm going to move to the next question. Okay, this is very similar to the previous one. Can I give you a few minutes for you to do this? A continuous and aligned fiber reinforced composite is to be produced consisting of 30% volume, 30%. So your VF is 0.330 and VM is 0.7, isn't it? Polycarbonate matrix, the mechanical characteristics of these two materials as follows, and we need to find the longitudinal tensile strength and the longitudinal modulus of elasticity. Okay, so how you just put the numbers in the two equations. So this one will be what? So this is the fiber, so that will be 131 times 0.3 plus 2.4 times 0.7. So that will give you the stress. Sorry, it is the modulus of elasticity. Modulus of elasticity. So the stress will be 3600 times 0.3 plus 60. It is 45 actually. Even though they have given you 65, this is it is failing at polycarbonate matrix when they made fiber. It is failing at 45 megapascals. Okay, so you can't consider the 65. You need to consider the 45. Make sense?
Can you upload this tonight, please?
Yes, yes. So 45 times 0.7. So when you put the numbers in the calculator, what do you get for these two? First one is? Let me check. Yes, 41 gigapascals, right? And this one? 1100 megapascals. Okay, so we have found the A and B. Are we good? Any question? So composite question also very easy. 45 is, even though this one is 65, they are saying together. When we have both together, it is failing at, polycarbonate is failing at 45. So we need to consider the 45, not the 65. Because it can't reach up to 65. Before that it is not the fiber. With the fiber, the polycarbonate is failing at both together. When they are staying together, the matrix, yes, as a composite, the matrix is failing at 45. Are we good? Any question? No questions? Okay, let's move to the next one.
Why do we use what was the number behind the?
That is PSI.
So we don't use that.
No, we use this gigapascal. We don't use the PSI. Any other questions? Can you answer these two questions, please? MCQs. Fiber orientation and the concentration plays a significant role in determining of the composites' thermal conductivity, electrical resistivity, mechanical properties, or optical transparency. Mechanical properties. Next one. Sandwich panels are an example of fiber reinforced composites, laminar composites, dispersion strengthened composites, and large particle composites. Where do you have sandwich panels? So you have panels like this, So they are like, like this, panels. Fiber reinforced is like, they are not panels, they are like, they have fibers in that. Laminates, yes. So have you seen any, these ones also maybe laminated sheets, many things together and packed. And like, for example, have you seen the cardboard, the corrugated cardboard? Have you seen the corrugated cardboards, the cardboard boxes? You can see that. So likewise, you have panels, and also these ones also, they are laminated. What's that?
This because it's horizontal, then it's laminar.
Sandwich panels, no? They are talking. Do you eat sandwiches?
Yeah.
What do you have? You have a piece of bread. You have the ham. Yes. So you have. So you have layers. Am I right? You have bread, you have the ham, and you have the cheese, and you have the salad, and you have everything. So it is sandwiched together.
But for fiber, it's vertical.
Fiber can be, if you have long fiber, like fiber is like this, or else maybe if it is long continuous, it will be like that. Like the fibers are not plates; they are thin rods. They can't stay as a sandwich because they are thin rods. It should be in a matrix. It's like in a large scale. It's like you have reinforcement in a concrete. So that is not a sandwich kind of a thing, isn't it? And laminated, laminated sheets. There are many sheets together. Okay, you have some pictures in the lecture notes. You have a look, okay? I haven't copied it. Dispersion.
Because I know what a sandwich is, but
Okay. Now are you okay? Yes. Large particles are like aggregates and the cement, and the dispersion strengthened. You have some pictures in the lecture notes. Have a look. So only one with the panels are this sandwich kind of thing. Yes, they have an area, flat areas like pages. Okay, are we good? Any other questions? No questions? Okay, so we'll finish this one.